view controller, get the lay of the land. Damn, this looks a little overwhelming, but we'll get there. So now let me scroll back up to the top and see what's interesting here. So let's focus first on one of these at a time. So here's a method called initWithNibName. This has typically been called automatically for us because we've had a bunch of starting points in our applications thus far in class where we had those .xib files. Somehow they were wired up to my code and loaded automatically, and we just initialized them based on the XML file that is the .xib file somewhere on my hard drive. But now we're explicitly implementing an initWithNibName bundle method, and if I hover over this thing and check the question mark, notice that there's a whole bunch of documentation in here, and this method appears to come from an ancestor class known as UIViewController. So if we really look underneath the hood, master view controller descends from a new class that gives us the tabular view, UITableViewController, which in turn descends from the thing we've seen in applications thus far, UIViewController. So long story short, if I actually start to read this documentation, this will explain how the initWithNibName bundle method works, and it is the guy that's responsible for loading from the hard drive that .xib file and somehow making all of the connections we discussed last week and in lab. So it's doing one additional thing, though. It's calling first the superclass's implementation of that same method, initWithNibName bundle. So that's been called automatically for us because we have not explicitly implemented this method thus far. But it's also doing what in high-level terms, apparently? What does it appear to be doing? You seem to have a guess in mind. Oh, yes, you. Initializes the, oh, the first line does. Yes, sorry. Let me change my highlighting. So it's not commented, but what do these three lines seem to be doing? Yeah, it's setting the title of self. So self.title. What is self? What type of object is self at this point in time? So it's a master view controller, which in turn is a UI table view controller, which in turn is a UI view controller. So if we really started poking around the docs, we would probably see that UI view controllers have a property called title. And indeed, that's where this is coming from, or UI table view controllers. And if we go back to the application that was running, notice when we're here, the title master, that's where that came from. So we could have typed this in manually into the nib, but because we created the view controller in code, we don't actually have to do that there. All right, so this, as an aside, is a common paradigm. Anytime you modify self, it's common to check is self. If self is non-null, so that is if everything went OK and the previous line did not return nil, meaning there's some memory error or the like, you check first that self exists OK before touching one of its properties, as we did here with self.title. All right, so next, I think we saw this last time, Viewdidload. We saw this in our no-nib example, I believe. Viewdidload, if we read the documentation, is just the method that's called when the view did load, so aptly named. And what does this guy seem to be doing? It's wrapping a bit, but it's about 4 lines of code total. Yeah, it seems to be adding the edit button. So first we call the parent version of the method. And if we read the documentation, we will be reminded typically, be sure to call the parent before you do your own thing. Self.navigation.left button bar item. I don't really know where this comes from, but I can probably guess that because we are implementing a subclass of a UI table view controller, presumably a UI table view has a property called navigation item. And that navigation item refers to the little blue or gray bar at the top of this kind of application. And .left button item refers to .left bar button item refers to the thing at top left. And we seem to be storing what there? Self.edit button item, whatever that happens to be. And then UI button item, add button. So if we read this, we're apparently instantiating a UI bar button item, allocating it, initializing it with this thing, UI bar button system add. So there's a lot of code there. That's not all that interesting to dwell on now. But if you think back to what's going on, this is really just the code version of going to something like my nib, opening up the toolbar over here, scrolling down to the objects down here. And if we scroll, we'll eventually find navigation bar and navigation item. So what I'm doing in code is the equivalent of dragging and dropping this into the user interface, much like we were doing last week. So that's all. The magic that we've been taking for granted of dragging and dropping is now being implemented more lower level in code. All right, so let's not worry too much about the user interface, because that's not all that interesting at the end of the day. Let me just point out a few of the additional methods we've implemented. These are methods that we've implemented because we need to implement table-related functionality. One of these is super simple. The method called number of sections in table view, if you read the documentation, its purpose in life is to return a number, namely how many rows should there be in the table, so that the operating system knows when to stop rendering rows. So in this case, we've just returned, sorry, not rows, sections. So sections are groupings of rows together. And if you have an iPhone and you go to your settings menu, you'll see that there are rows in your settings menu, but they're typically clustered with some kind of bold header. That's referring to a section. We had no such aesthetics here, so we just have one massive section. So they have hard-coded the value of 1 in this template. So next, table view, number of rows in section. So this is the method that tells the program how many rows should actually be in that table, how many dates have been added to the table. But what is underscore objects dot count? Where did that come from? Yeah, it probably holds the information for the rows because, again, recall the difference between C and V, controller and view. The view may very well render what looks like a table, but if there's any data that you're rendering, it's the controller's job in life to actually keep track of that and just pass it to the view. So we shouldn't be storing those dates in the view per se. We should be storing all of those dates after every click of the plus button somewhere inside of my controller and then just handing it to the view. So underscore objects, if we glance back at the top of the file, was actually declared up here. And I've declared an NS mutable array. What's the difference between mutable array and NS array? You can modify it. So it's mutable in that you can change it. You can add, remove to and from it. So I've done @interface master view controller open paren close paren. So again, we've already did that, I thought. In the .h file, we had @interface master view controller open curly brace. Why have we repeated ourselves and added these parentheses? For it to be private, or to the illusion of privacy. So we've used an unnamed category here. So recall that categories are just ways of grouping related functions, but the world as a convention has adopted it as a means of approximating the idea of private methods and private data members, private only in the sense that they are not being declared to the world in the .h file, because .h files can be imported by other people, which means other people would see our implementation details, but they're nonetheless adding it to the class master view controller because it's inside of this declaration. So we apparently have an NS mutable array underscore objects, but where is that guy first used? Well, let me scroll down and scroll down and scroll down, and it looks like, let's see, where's our underscore objects? There we go. Exactly. So here we have a method, insert new object, colon. So what do you think is inducing this method to be called, based on what we've seen thus far? So hitting that plus button. And how was that done? Was it done in Interface Builder, or? So insert new object. So again, let's just do a little highlight and copy. Let's see where, oh, interesting. So Viewdidload, we didn't finish that story. We, and Apple, did not use Interface Builder, it seems, to wire things up. They've done it all in low-level code. So in Viewdidload, we started telling that story in terms of the left button bar item. If we go a little deeper, notice what's happening here. When we declare this UI bar button item and allocate it and initialize it, we are choosing, this is a constant. This very long word, UI bar button system item add, is just the atrociously named constant for the plus icon. That's all that's doing. It's aesthetic. But we're saying target : self action @selector insert new object. So first of all, what is action : @selector insert new object doing functionally? Exactly. When some action happens, which in this case is going to be the touching of the button, that's the default behavior for one of these buttons when it's clicked by a user's finger, what message do you want to send to an object? You want to send this message, insert new object, or put another way, what method do you want to call, and to which object will that message be passed? On which object will that method be called? The target. So target colon self means this class, this object, and that is why, slightly more lower in the screen, we have an implementation of the method that we want to call. So as an aside, the reason that we have this funky syntax, at selector, open paren, close paren, is so that it's clear what the name of the message is that you want to send, because we've seen methods that have colons in them, and it would just get very complicated, if not impossible to parse the string if you had action colon insert new object colon which colon belongs to what. So that's the idea of at selector. It's just a syntactic thing. So that means when you click that plus button, this guy is actually called. So in answer to the question, where is the object's NS mutable array coming from, we instantiate it lazily. The first time we need it, we check, does it exist? If it doesn't exist, that is, if underscore objects equals nil, we're going to go ahead and instantiate an NS mutable array, and then we are going to start populating it. And at this point, if you start to read through the code, you'll see a couple new features. There's this notion of index path, which is something specific to these UI table views. A path is just a tuple of numbers, two numbers together, a section and a row. So an index path is just an object that contains those two values, and if you keep reading further in the code, you'll see that this is the function that actually does the generation of and insertion of a date into that actual table view. Yeah?
A question about, say we would have a property for the object's variable.
Okay.
Would it be faster to use the object with the underscore?
Good question. So suppose we had declared objects as a property. There would be a couple of implications. One, we could do self.objects and mutate it that way. On the other hand, so could anyone else who happens to be importing, for instance, my .h file. If we declared the property there, though we don't have to declare it there, you would get some marginally additional functionality, because by default the setter and or the getter will often have additional code in them. For instance, if you declare it to be atomic, it will have some additional code. With the setter will by default make sure that you never set an object equal to itself, which can do some bad things circularly. So you would get some protections, but you pay a price. What's the downside, would you conjecture, of using a property to implement this container as opposed to just declaring a raw pointer like this? It takes longer, and we're talking, negligible amount of time for something like this, where clearly I, the human, am the bottleneck for any slowness in this application, how quickly I can press. But in theory, that's why they've done it in this way. We're the only ones using the property, not the rest of the world. I know how to use it. I just don't need the marginal overhead of a setter and/or getter. But a good question. Okay, so let's not spend too much time on the particulars of this specific application, but let's just scroll through, lastly, the other methods that might be here. So there's this one, table view, cell for row at index path, because this one method actually reveals an interesting design pattern that's not uncommon, especially for performance reasons. So table view, cell for row at index path, and then it's given an index path. The purpose in life of this method, if we read the documentation for the UI table view parent class, is that it is supposed to return a cell, a UI table view cell, so an object that represents a cell in a table configured exactly as we want it. And by configured, I mean what text do you want for the cell, what buttons do you want on the cell, what behavior do you want for that cell. So in short, this method is called when rendering this row, then this row, then this row, then this row, then this row. It is my job to tell iOS how I want each row to look and behave. So what's interesting, though, about this implementation is the following. One, we have this static pointer declared here, cell identifier, that points to a string that's statically declared as quote-unquote cell. This is completely arbitrary. It could be quote-unquote foo or bar or any word there, but it's going to be used in the following way. Down here, I declare UI table view cell, table view DQ reusable cell with identifier quote-unquote cell, quote-unquote foo, whatever word you've chosen. So what is that doing? Well, I'm checking if cell equals nil. That means that there apparently was no reusable cell in my queue. So nothing came back. And so what do I proceed to do? Well, it looks like a common paradigm here. UI table view cell, allocate it, then initialize it with some long, crazy named constant, and also give it a reuse identifier of quote-unquote cell, or quote-unquote foo, whatever word you've chosen. Then lastly, change the accessory type to be UI table view cell accessory disclosure indicator. What is that? It's like the little eye icon or similar on the screen. All right, so or rather the little arrow that points to the right.